Hey guys, Mr. Riz here to help you out with the 215 part 1 and actually part 1, 2, and 3 video. So today what we're going to be looking at first is sloppy code and how we can secure that. So this one here, we're going to make sure we can identify the logical errors and syntax errors and runtimes errors. And we're also going to try to optimize code using Boolean expressions and selection statements interchangeably. We're going to try to also debug programs using debuggers to visualize the running code. And we're going to test out programs that using test causes, which the user defines inputs and expected result values. So, hey, how's it going? Hi. All right, sorry about that. So far we've learned that there's many security problems on the internet that are due to just like personal security measures, such as like weak passwords or a lack of authentication factors. Many other security problems are due to error flaws and design flaws in the software that runs on the internet. So although companies try to create the best software, malicious users know how to exploit and take advantage of the design flaws or bugs in the code. They can use design flaws and really just poorly written code to inject or insert their own malicious software. So let's look first at logical errors. So condition statements like if give a programmer the power to use logic into their program, but they also increase the likelihood of bugs or logic errors. You may not know that every time you add an if statement, the likelihood of a bug increases or introduces go up approximately about 30%. Sometimes our if statements are written incorrectly, but they can still produce a runnable program. So to reduce the likelihood of bugs, you can optimize your code to reduce the number of if statements in a program. So let's explore some of these scenarios here. So we're going to run this program and answer the questions with the Y to indicate if they have a good security habit. All right, so let's look this open here. I'm going to just open this in a tab. And we can go through here. Okay. So let's see, answer Y to the following. Like, so are you able to recognize phishing emails? If you can, well, we'll enter Y. Do you have a strong password here? Hopefully you do now. After doing the password activity, you realize, okay, your password is strong. If not, hopefully you'd say yes. All right, do you know how to use the multi-factor authentication? So how we can check for different things, different level, not just the authorization using your password, but the authentication, checking to see, if you know a secret answer to some question. And do you know how to encrypt sensitive information? So you understand how the encryption key works with our paired keys that we do. If you do, you have good security habits. Now, if you ran that again, you have that, but you don't have a strong password. You go through there. All right. Actually, did that just supposed to print off something else? Do you have a strong password? No. Yes, yes. Oh, that print statement did not print off. Oh, okay. Maybe we need to change that up a little bit. So why doesn't a message appear? So let's look at this here. And one of the messages doesn't appear. We should have a no. You should say you should improve your security habits. Kind of found that odd, right? We were expecting that since I guess no here for the strong password, but it didn't tell me to do anything different. Okay, so although it's not written to do so, the program should display the message, you cannot improve your security habits. If any of your answers are no, that means the program has a logical error, unlike a program with syntax errors. So programs with logic errors or programs with logic errors, they still run. They should behave unexpectedly or incorrectly. So let's try to think of some ways that we can fix this logical error. Perhaps we can add some else clauses at the end of each if statement. Adding the statement would result for duplication of segments of codes and be more ineffective. So the more efficient solution would be use the and or not operators of a Boolean value. And just to make sure you guys remember some Boolean logic here is that a simple rule of thumb is like, do all the Boolean expressions need to be true, or can any of the Boolean expressions need to be true? So if all of them need to be true, you'd want to use an and. If any of them, you need to use an or. So what I want you guys to do first is to go through and fix this code. So if anybody types in a no for any of these answers here, we get the print. So we don't really want to be checking here. A lot of different ways you guys can do this problem here. You could create a list of answers. You could create a list of yeses or combine these all to and statements. So maybe we'll do that way. So maybe I'm just going to go Control X and paste that out. Yeah, make sure I forgot copy that colon over. Control X, put another and then probably need another and. Oh. All right, and we can just get rid of all those ifs. Since all these need to be true for the statement to say you have good security habits, and then the only thing else would be if you ever have a no or something else, you should say you should improve. So let's test this out. Let's just double check everything was a yes. You have good security habits. Oh man, I just realized I didn't fork this. If I say yes, yes, no, yes, you can improve. Okay. All right. Let me pause this video while I go back to the original. Okay, so once you got this done, go ahead and submit that to Canvas here, and we will move on to part 2. So once and then, these are really small parts that we're going to just kind of do together. Some are quizzes and some are going to be like submittables on Ripple. All right, let's talk about runtime errors. So as the name implies, a runtime error occurs when a program is running. Often runtime errors are due to unexpected input or data. So let's take a look at this code here, and we're going to kind of record the public key and private key in the modulus. So we're going to open this up here, see what we're looking with real quickly. Okay, we have, hey, this looks really familiar, right? All right. And what we want to do is we want to run the generate key program. So, you know, I'm going to do like we did before. I probably should have done this. You know, I'll do this so you guys don't have to right now because this is the main P file. I'll just call this the cipher.py file. And I'll Control A, Control X, and I'll just paste this here. Okay. So there you guys, you should have it set up. All right, so now I'm going to just fork this so you guys don't have to deal with this. Okay, so we're going to run the generate keys program here. So Control A, Control C, Control V. All right, let's run this out here, and I'm going to write this information down on a piece of paper. So I got my public key is 23413. My private key is 2437, and my mod is 25159. Okay, let's go back to this quiz here. All right, so we could test out the encryption and decryption values for this publicly, but next we're going to look at the run RSA encrypt program that we've used before. Okay, so let's go ahead and do that. You provide a short encrypted message to finish the program with. So let's get the run encrypt. So we're going to Control A, Control C, and go to our main py file and run that now. Okay. So let's see, we're going to open and run it, and we'll enter the appropriate key and modulus values and just the integers that we get there. All right, so our encryption key that we were using, so if we're going to encrypt, we use the public key, which is 23413 for me, and the modulus, which is 25159. And the message we want to encrypt, does it say provide a short encrypted message to finish the program? Oh, I'm just going to be like, let's test this out. Okay, so we got that. So we run the program again, and we'll supply an unexpected input key such as modulus. So what we're going to do is just run this program again, and we're going to get different letters, or we're going to go through and see like if we just changed we messed the modulus up. So maybe, you know, we take a note, look here, I'm going to copy this here, and I'm just going to put this down here just to save it. So like the original message equals, okay, so that's just a value stored there. So the encryption key, I'll go ahead and do the 23413 exactly. Then the modulus, I'm just going to mess up. I'm going to do 25519, so I'll mix like the 1 and the 5 up. and I'll press enter here, and let's try this out, or let's test this out. Is that what I said too? I already forget what I said. Okay, so what ends up happening, this code still runs, and we don't get like any different symbols or anything like that. What we end up doing here is going through and we get the just different integers. So run the program again, supply an unexpected input. What happens here? The program still runs, we just get different integers. Now, running the program with the incorrect input exposes the runtime errors and indicates a design flaw. The program should be able to imagine all types of inputs, even input that doesn't want or the user provide. Let's even like try this again. Let's really mess this up. Let's do something. Encryption key. Let's type in the 23413 and type in the modulus. Okay, so there we go. We got an error because that was going through. So there is some kind of like design in where we have to enter in integers here, but still, if we enter the wrong integer, it doesn't work. All right, so to fix this flaw, we're going to use a new method called the isDigit. So we're going to determine whether the method, oh wait, I guess this is the encryption. Do we want to run the encrypt or decrypt? Well, anyways here, we want to make sure we understand what this isDigit method is. Oh, is that what I was talking about? Maybe this was supposed to be talking about decrypting. Yeah. Yeah. Oh, okay. Well, the error is this program just kind of crashes too. So I guess we can still use the isDigit to help us out. Okay. So we are going to use the isDigit for the next part, really. And the isDigit is a method to see whether something that was typed in is a digit. So we want to predict the output here, and we can do a lot of different tests to see which one works out. So just to kind of show you guys out, I'm going to copy this code in here. In this first one here, I'm going to go to main py file, paste this over again. My variable equals 4, and we're going to print if myVarie.isDigit. As you guys can probably assume, the .isDigit will check to see if that variable or that variable there is a digit. And again, it says true because 4 is a digit. Even though it's set up as a string, the string can get converted to a digit, and it is a digit. All right, so that's true. All right, what about is 1, 2, 3, 4? Well, yeah, 1, 2, 3, 4 is a digit. It's a 1,234. That'd be true. All right, what about this one that has a comma in the middle? Typically, we would go ahead and check that out. We would assume that is, but that returns a false. So digits, I guess, have to be just a single string of numbers or integers put together. So there's a comma in there that separates it. That isn't right. All right, 1, 2, 3, 4, ABC. That probably doesn't work out because that has ABC. Those are variables. What about just like not even using a variable, just like string 123.isDigit? That one returns true. So we don't even need to name a variable. If we just type in a string of digits, we can still use the isDigit. All right, submit that quiz. Ooh, we have one. Oh yeah, there's that one short answer part. Yep. All right, hopefully we're good there. All right, last part 3 here. We're going to improve our RSA encrypt so that it handles all sorts of inputs and it won't crash when somebody types in a like non-digit. So once again here, our RSA encrypt, Control A, Control C. I guess there's a couple problems, but a big problem here that we want to first address is what if we type in a value that isn't a digit? What if I type in 1, 2, 3, A, B, C? We just get it to crash. It would be nice if it just said like, hey, type in an integer instead of like that, instead of just completely crashing. All right, so we're going to try to go through our code here and test some things out to see. If you think about it, we first want to just double check that the input that they sent for RSA is a digit. If not, we want to re-ask them a question. So you can kind of think about that statement that we just said in our head. While that is a digit, we're going to move on. If it isn't, we'd go through. So like while the question is not a digit, we're going to have to answer them or ask them that question. So, okay, so if you look here, it says like key equals integer input, enter a key. So we are already changing it to an input. So maybe we want to go through and just say while key is not a digit. All right, so let's fix that up. And there's a couple different ways we do it. The way I would initially think of doing it is initializing key as something that is not a digit. And then we could say, make a while loop here to make key. So we can say while key dot is digit does not equal true. Actually, we're going to do capital true. Okay. Okay, so let's check this out here. So let's first check the key here. That's the only thing, the encryption key run. Already getting a, that is, oh, in digit is digit. Okay, we get enter encryption key. I'm going to type in something wrong. I'm going to type in 123C4. Okay, so it asks for the integer here to change that, and the input is already going through. So this integer part, we're going to eliminate now because we still want to take the input from the user. We just don't automatically want to convert it to a digit. Okay, so enter the encryption key. So we can go through 123C4. Okay, still pops up again. Enter the encryption key. Maybe we should have it print to help us out. Print. Oh wait, no, we want to do that probably before, right? Print. Please enter a digit for the encryption key. All right, so please enter encryption for or digit for the encryption key. I'm going to still lie to them. All right, please enter a digit. So it goes through it. Okay, now let's enter a digit. 1, 2, 3, 4. All right, now it goes to the modulus. All right, so modulus, we'll type in a number here. Actually, we'll type in letter. Okay, it crashes. So we pretty much want to do the same thing for mod value, right? Mod value equals, we're going to set it up as false anyways. ABC again. All right, so while mod underscore value dot is digit does not equal true. All right. We want to go ahead, have the mod value enter an input. We'll get rid of the integer part too. I'm going to copy this print statement over here as well. And okay. So let's see, then we'd have our plain text that gets encrypted. So let's see if we can get this to run. So I'm going to first falsify this. Doesn't work out. So then I'm going to type in a number 23413. Okay, we know that works. Enter modules. I'll make up a fake one that doesn't work. Still ask me to do another one. All right, so I'll fix that 25159. All right, enter a message to encrypt. All right, hope this works. All right, we get an error. And now the error is because the encryption that we get as our input is a digit, but it hasn't been converted to an integer. So what we need to do is after the while keys end or while loops end, we're going to have to then convert the key. So we can say key equals the integer of key. So we need to make sure after we find out that it is a digit, we turn it into an integer. And the same thing with the mod value. And we put that after the while loop because the while loop will end once it is a digit. Okay, so let's see. Really test this out, falsify it. Doesn't work. Pick one that works. 23413. All right, make a fake one that doesn't work. Doesn't work. Now try one that does. 25159. Message to encrypt. Hope this works. There we go. We can encrypt it now. All right, so we got this now. So the design or the program doesn't end even if the user types in an error. And we've kind of fixed the flaw here. All right, hopefully you guys had some fun doing this and you kind of learned some things. And we're going to try to improve the decryption part as well. You guys have a great day. I'll see you next time.